Ladies and gentlemen, welcome to the class number 3.2. Just in order to make a little bit clear the structures of this lesson, I want to mention that this class is divided mostly in two parts. Each part is divided in two blocks. So we have the part number 1 and then the part number 2, which will conclude completely the course of artificial intelligence, at least for this year. In the future, I think we will add more module in the explanation of this complex topic. Simply because artificial intelligence and architecture and urban planning, it is a very wide topic, very new, and so the process of discovering is still open. This is why, at the very beginning, I decided to start the class about artificial intelligence, but somehow I cannot see any end. Probably we will develop this class in the following years. So anyway, for this block, for this moment, we will have a sort of partial end. So in these figures, you can find the structures of the last branch of this course. So the lesson 3.2, it is divided in part 1, where we discuss some inspiration from the past and some current developing of artificial intelligence and architecture. Then we discuss about some general issue about artificial intelligence and architecture, but in terms how artificial intelligence can operate inside the architectural design. Then we discuss some element about parametric and artificial intelligence. This is the part 1 of the class 3.2. And this part 1, it is divided in two blocks. The first part concerns some investigation from the past. We will touch some discovery made by Fry Otto, and then some process from the famous company Zaha Hadid, because they are quite experienced in parametric and architecture. Then, thanks of the help of one of my brilliant students named Zhao Yafei, a very promising Chinese guy, we will investigate some operational process in the self-generating architecture. This is the first part. The second part, we are going to investigate something a little bit more complex because we are going to find out some parametric tool and process which can help the architect to generate architecture in its own complexity. So the first part, it is something like the past, plus some very inspiring information from my students Zhao Yafei. And the second part, which is made more by myself, it concerns operating process, some method of creation in artificial intelligence and architecture, but more focus on parametric. Then, in the second section of the part 1, we will discuss about genetic algorithm and process. If in the previous class you have seen something about a theoretical element of genetic algorithm, what is that, how it is composed, what is their function. In this class, we will discuss more about how it works, how can be used. This is a very important point, and we will see that there are a lot of very interesting applications. In the case of the part 2 of the lesson 3.2, which is basically, we can call it even the lesson 3.3 actually, because it's so different, even if it is linked with the part 1. In the part 2 I mentioned, we will discuss how to operate in terms of cellular automata and architecture, which experiment is done by some scholar, by some company on this field, and we will see that is very promising. We have a lot of very interesting experiment and practice using cellular automata and artificial intelligence. We will see that there are still a little bit theoretical, there are a lot of problems, the result sometimes is not very convincing, but it is a very good beginning, and I'm sure that in the future a lot of those problems will be solved, and the future is very close. Then, in the branch 2 of the second part, we will discuss more deeply about the genetic algorithm and artificial intelligence, and then we will touch about a very difficult concept, which is a neural network, and how the neural network can be used inside architecture and urban planning. This is a very complex topic and very technical. I'm not going to introduce you any coding or any process of operating, but at least the general element of the neural network, because this is a very promising methodology to solve architecture and urban planning in the very near future. So, this class is very articulated. I hope that it is clear enough the structures of our course, and then let's begin. Let's go into the end of this course. Let's start to fix some point in our discussion. In the field of artificial intelligence and architecture and urban planning, we touch several big blocks, we can call, several topics, which is all included inside the artificial intelligence and, in our case, architecture. For example, parametric architecture, for example, cellular automata, for example, genetic algorithm. These are three key topics in our discussion. We have seen that, yes, they are inside the idea of artificial intelligence, but artificial intelligence, and I intend the strong artificial intelligence, not the weak artificial intelligence, we say that the strong artificial intelligence is still at the beginning. For sure, the human being, we will reach the strong artificial intelligence, but for now, we have a lot of work to do to reach that level. Then the question come out and we say, is parametric very intelligent? Is cellular automata intelligence? Is genetic algorithm intelligence? Are the neural network intelligence? We can see that there are sometimes some overestimation of this topic. Parametric architecture, for example, cannot be completely discussed as intelligent. But at the same time, there are some issues which is definitely related on what we call intelligence. The same for cellular automata. Somehow, I believe that everything which can be considered self-generating, everything that has a sort of independence by the action, by the direct action of the human being, but it constructs something that it makes sense for us, which has some function, which has a sort of finalization of their action, we can call it intelligent. I give you an example. Very often with our pet, a small cat, a dog, and so on, when they do some action which for us, human being, makes sense, for example, build a nest, for example, feed their child, and so on, we can call that behavior intelligence. So, intelligence for the human being, it is some human action reflected in non-human entities. This one is a very simple and very poetic, you can call, definition of intelligence, but somehow it makes sense. So when in the computation, in computer field and so on, we can recognize some action that makes sense for us, human being, action that are independent by our own intervention, we may call that action intelligent. Parametric is not completely intelligence because there is no entity, no mind which can be considered intelligent. It is a very interesting process based on a sort of automatization, automatic process, which generate output. Those outputs are partially independent by the activity of the human being, and then the action makes sense for our human being independently by our intervention. We call that part, even if it is very small, even if it is very simple, intelligent. In my personal opinion, all those fields, parametric, cellular automata, genetic algorithms, neural network, they are intelligent. I repeat once again, in my perspective, intelligence, it means some operation independent by the human activity, but the result generates sense for us human beings. We call this process intelligent. Now, we can touch the idea of parametric tool and investigate the process. To start our discussion today, we take as inspiration the very famous paper made by Patrik Schumacher, partner in business of Zaha Hadid and now the head of the Zaha Hadid office, called Parametricism, a new global style for architecture and urban design. This paper is very famous. I think it's not scientific, it is more operational, but they have some element which is quite interesting, at least at the beginning of the paper, which is very useful for us. So, from the past, very interesting element in the discussion of Schumacher is the reference of a very important genius, I can call, of the 20th century, who is Fray Otto. Fray Otto is an engineer. His background is engineering, and he is one of the top scientists, the top engineer, architect, as you want to call, in the idea of lighting structures, and definitely one of the key personality in the bionic approach. It is not a case that Patrik Schumacher mentioned the idea of Fray Otto because, and this is probably the most interesting part, in my personal opinion, about the paper of Schumacher, because Schumacher linked very deeply the parametric operation, the parametric architecture, with the bionic approach of Fray Otto. Let me make more clear. We already understand in the previous class what is parametric. You can check in the previous lesson. No need to repeat again today. Parametric, it is the main operational process of the Zaha Hadid studio and Patrik Schumacher activities in the last 10 or even 20 years. So it is a very clear trend based on a sort of automatism inside the process of design. The computer become a partner of the architect, part of the solution of the architecture. It is self-generated by the computer, and so on. We know everything. But why Schumacher refer his job, or at least quote the work of Fray Otto as a background of parametric architecture? This is very interesting. In many cases, in the past class, we have always a reference about bionic. You heard this word many times. It is one of the expertise of our studio and the main name of my lab in the School of Architecture of Tianjin University. Parametric and bionic. Why this link? I remind once again that bionic, it doesn't mean the copy, the mimic of the natural form into architecture, that it is more zoomorphic, phytomorphic. Bionic and architecture, it is more understand the process inside the nature and then use the process, the abstract process in the nature inside architecture and urban planning. So it is something a little bit more abstract than the simple form. The form is what appears, but behind the appearance there are a much more interesting process which is hidden. Very often those processes follow a very strict mathematical rule. So we must discover how the nature works, what is the hidden structures, the hidden process of nature inside the forms, and then eventually take inspiration from the process. This is bionic, and this is the main concern of many architects from the past. I just quote some of the most famous. Fray Otto, it is one of them, but also Antoni Gaudí, it is deeply based on bionic, and so on. There are many other authors which work on this field. Another very famous engineer is Heinz Isler from Swiss, who work with the upside-down structures. I publish some papers about this topic. I don't want to insist more in this class, but in the future we will have an online course about bionic architecture. This is my promise. Schumacher quote Fray Otto. So the question is why we have a sort of connection in between parametric and bionic. In fact, I strongly believe that parametric, cellular automata, genetic algorithm, neural network, they are all application, or better, computer application of the bigger field of bionic. So it is very coherent with bionic. It is something like a sort of mechanization of the process of bionic. If in the past, authors like Fraiotto or Heinz Isler or Anthony Gaudí operate using the idea of bionic, but using scale model, physical model, nowadays the experiment on bionic can be done by computer. And I quote a very little example which comes from our own practice in our studio. In the past, to generate a certain kind of model, some author, some engineer, and also us in our studio, we use the soap bubble, because the soap bubble have the special characteristic to generate minimal surface into a certain boundary. I'm not going to discuss the details of this experiment. Now, the soap bubble can be generated by a very simple process. You can use a ring or a boundary, then you put this boundary inside the water plus some soap, very common liquid soap, for example. When you take off the model, the physical model, a film of soap bubble, it is generated on your model. And then you can start to study with the lighting and so on to understand the form. But in the last 10 years, more or less 10 years, there are very interesting plugins in some software. For example, there are plugins in Rhino. For example, there are plugins even in SketchUp, which is able to create soap bubble form exactly like the physical soap bubble, but with the convenience to be faster, to be more accurate, to be more usable in terms of design. In my personal opinion, it will be always a difference in between the physical soap bubble and the soap bubble generated by computational. But in this moment, it is not very interesting to discuss those differences because it belongs to another field, the bionic field. So the idea that Schumacher quote Fraiotto in the parametric architecture, it's very coherent and it is very interesting. He said that Fraiotto is a pioneer in the discussion of natural structures. In specific, Schumacher analyzed the patterns of Fraiotto. So Fraiotto generates a lot of very interesting structures. He generates a lot of very beautiful work which is not directly related on patterns. In the case of Patrik Schumacher, he only analyzed the projects, the experiment made by Otto concerning patterns. In this moment, we are not going into the details, but what it is interesting is that part of the work of Fraiotto concerned the understanding, the creation of natural pattern inside some physical model. What does it mean? We all notice, but Fraiotto noticed better and with a much higher methodology, that the nature creates patterns. Patterns, it means a sort of texture, a sort of relation in between physical elements which constitute a sort of order, a sort of models which has features, which has rules. In specific, Schumacher referred about two experiments of Fraiotto, and we read together. These experiments concern the distancing and attractive occupation. Distancing, it means some process, for example, using magnets floating in water, which separate metal particle thanks of the magnetism. So it is a sort of repellent, natural repellent. Those kind of forms, it is self-generating, following the natural rule of the magnetism. It exists another experiment where Fraiotto used floating polystyrene chips. Polystyrene chips, there are those kind of material which is using for packaging. He throw into the water, and then he finds something very interesting, because the polystyrene start to attract themselves in a very unusual pattern. Attention, this unusual pattern that you can see in this picture, it is very interesting because it is not chaotic. We know very well the difference in between chaos, random, and a pattern, we can say. In these two pictures, we can see something quite important. First of all, we are not in front of randomness. Randomness means pure disorder. Chaos is a concept which we use several times, but the common use of chaos is wrong. Chaos simply means in mathematics when a certain kind of process cannot be predicted by the initial condition. In this specific case, we are in front of polystyrene chips thrown into the water, and then for some natural characteristics, all those polystyrene chips start to attract each other. From the initial condition on the left side of this picture, finally, after a certain time, the figures appear like on the right side, which it means there are a sort of attraction. Polystyrene chips float into the water and then generate pattern, generate structures. Those kind of structures are very close to the urban pattern. Schumacher used a very precise sentence, which is very nice. The result closely resemble the typical settlement patterns found in our real urban landscape. So it seems insane to use the floating chips, polystyrene into the water to study the urban pattern. I mean, a city, it's a city with his own complexity, with his own idea and dynamic, and definitely they are not polystyrene chips. Why we call it genius, a guy who confuse polystyrene chips with a city. But the point is, Fraiotto was not crazy at all. He was one of the greatest geniuses in the 19th century, exactly for this kind of experiment. The brilliant idea in this kind of experiment is to understand not the comparison in between polystyrene chips and urban planning. But the great idea is to understand the system of aggregation. In both of the cases, we are in front of a natural process of aggregation. Somehow, in the cities and in the polystyrene chips, there are logic of aggregation, dynamic of aggregation, which generate patterns which are very close each other. The pattern of the city and the pattern of polystyrene chips are extremely similar. And this is not a case. It is not a case because the nature it works following identical rule at different scale. The big mistake is to confuse the polystyrene chips aggregation and the urban structures. They are completely two different stuff. A city is a city. Polystyrene chips are polystyrene chips. There is no connection in any possible perspective. Finish. That's it. No discussion. What it is interesting is the bionic approach. The bionic approach said it exists patterns which are very close in between polystyrene chips and urban structures. So the idea of study, the investigation, it touch not the form, not the combination in between polystyrene and city, which doesn't exist, but the key point of this investigation is the pattern, the mathematical rule, the natural structures in between the two, and they are extremely close to each other. Visually, this is very clear, but much more interesting is the process, the idea, the mathematical rule, the structures behind that two comparison. This is extremely interesting. And the mathematical logic of the polystyrene chips aggregation and the city development, they are very, very close to each other. This is the investigation of Fraiotto. and this is why he is brilliant. This slide shows very clear the meaning of the previous picture. What Freyotto pointed out in his experiment concerned the idea of continuous networks. So the floating particle of polystyrene inside the water create pattern, which it means create a sort of relationship in between the particle, which create organism. Don't be confused. The form, it is only the appearance on some inherent logic, inherent structures. So what Freyotto point out, what he remarked, what he studied in his experiment was not the form, but was the idea of continuity inside the network of polystyrene particle. Then we read together. Freyotto create three fundamental type of configuration in these polystyrene chips. Number one, direct path networks. Number two, minimal path networks. Number three, minimizing detour networks. The key element in all this stuff, in all these three important points is the ability of self-organization of the particle into relatively optimized solution. So, without any human intervention, only for the characteristics of the material, or better, only for the characteristics of the physical matter, they organize themselves into structures. Optimize structures. Yes, because of these kind of structures, they have a very precise characteristic. And Freyotto mentioned three qualities that we described before. More in detail, for minimal path networks, Freyotto devised the soap bubble skin apparatus where a glass plate is held over a water surface, and the minimal path system forms itself from needles. Which it means, the topic is very complex because we touch bionic. I can't go into the details, but the idea is very clear. In any direction you look inside the natural system, inside the physical system, you find a coherency. Soap bubble or floating polystyrene particle, they always organize in terms of minimal path, minimal surface. Why? Why we have this idea of minimal path, minimal surface? Very simple, to save energy. That is very critical. We are not talking about parametric artificial intelligence in this moment. We are talking about bionic, but please be patient a moment because there are strong connections. The nature, and this is the teaching of Freyotto, but also the teaching of Richard Buckminster Fuller, the nature work in terms of saving energy. Completely on the contrary, on the human being, we like waste energy. But in the natural system, when a system perform using less energy than others, simply win because it is more performative, because it is much better. I can give you a very simple example. If you want to go from one city to another city, the most logic way is to use the closest route, or better, the most easy route, the route that let you spend less energy, less time, less oil, less energy in general. It doesn't matter. You are not, if you want to go to one city to another city, you are not going to use the most complicated, complex, difficult, dangerous path. The path that lets you spend less energy, it is much better. That is very clear. It is common in our life. The soap bubble, it is so interesting, for example, because they are minimal surface. Minimal surface because naturally the soap film try to use as less material as possible to close a certain kind of boundary. Using less material, it simply means use less energy. Attention, this is not the rule of the universe because there is many structure which use a lot of energy, waste a lot of material. But there are other reasons which unfortunately I cannot express very well in the limit of this class. In some cases, the nature use a lot of materials, or better, more material than the minimum one, simply because it is more safe for the replication of the system. For example, this is very clear in the engineering, for example. When we design a bridge or a skyscraper or a structures, the pillars are not the minimum necessary to create the building, but there is some coefficient which enlarge the minimal surface in order to be more safe in case of unexpected situation. Earthquake, accident, wind, typhoon, and whenever. So every structure designed by human, for example, but it is completely the same for the natural system, it is a little bit bigger than the minimal necessary for existing. This excess of material, it is a sort of safety system. Something like you are going to a restaurant, you know very well that you have to pay, for example, $10 the dinner, but somehow, in order to be safe, you take $15. You know very well that you're not going to spend more than $10, but plus $5 could be safe. Or when you go out, maybe you live in London, and then even if it is not raining, you get the umbrella because it is simply more safe. Something like this, but of course in a much more complex way in terms of natural system. So the minimal path networks, the minimal path system forms, and so on, it is a sort of natural process which minimizes the quantity of material, the quantity of relationship into a natural system in order to save energy. The absolute minimal, in most of the case, no. Sometimes yes, like in the soap bubble, but in most of the cases there are a little bit waste of material, a little bit waste of energy in order to be safe. In the system of the previous figures, the floating particle of polystyrene, what it is very interesting is it represents, we read it together, for the optimized turn networks, the famous wool trade models are able to compute a network solution between given points that optimize the relationship of total network length and the average detour factor imposed. It means, this is a complicated sentence, it means that in a certain kind of system, and the picture above, it is one of the case, the natural system are combined in order to be optimal. He said, optimize the relationship of total network length. So the energy, the total energy spent by the system for create that kind of structures, it is not the minimal, not the maximum, but it is optimized. That is a key concept in bionic, and this is why that picture is so interesting for us. So, in order to conclude this discussion, the system creates a sort of optimized solution. This is very clear in another experiment made by Fraiotto in 1988, which is also extremely beautiful because in this case, Fraiotto analyzed the minimal path system which connect a distributed set of given points. What does it mean? It simply means that it exists on a certain surface a series of points. In this case, the natural system optimizes the distance in between the points in order to give the minimum length of path in order to connect all the points. In other words, you have a lot of points on the surface. The question is, which one is the minimal length in order to connect all the points? This is the solution. And also very important, in this kind of system, there are no redundant connections. This is one of the typical points actually in topology. But in this case, Fraiotto used a bionic process in order to generate that kind of pattern. This is a typical process based on bionic approach without artificial intelligence. It is not a artificial computational. This is a bionic approach. Fra 8 use physical model in order to get this kind of output. In this case, we are in front of another bionic system, another bionic process, not made by Fra 8, but made by Marek Kolodziejczak. This case is also very complex, but in summary, in this case we have a kind of system, again it is a natural system, it is not computational, where the different branch, we can see this kind of antenna, this kind of ray on the external surface, they are connected each other by a natural process. In this case, the natural system automatically by its own generate a connection, a solution that reduces the overall length of the path system while maintaining a low average detour factor. It simply means that the connection in between the different array, in between this kind of antenna, it is not the absolute minimal, but it is simply optimized. The natural system optimizes the connection in between the different branch in order to connect anyone with the other one. All the different parts are connected to each other using as less material, as less connection as possible. The length of the different branches are optimized and minimized. And this is the very beginning, the very initial discussion about the work of Zaha Hadid and Patrik Schumacher. In this slide, Patrik Schumacher illustrates a very powerful and very interesting method that the Zaha Hadid office used for some urban planning, which is based on a very unusual software, by the way. It's a parametric software. It is one application, one plugin in Maya, the software Maya, for hair dynamic tool. Basically, it is a software to generate hair in the computer graphics. So every time you see a movie created by computer where the characters has hair, they are very realistic in their movement, well, that is a software. It is a software to create dynamic in the hair. It is one application, one function in Maya, and the Zaha Hadid office used that kind of software to generate forms. In the right side of the picture, you can see a very large area in a city, which was completely empty, and one of the questions of the project is to create a relationship in between the boundary of the city without any sign inside the empty area. So the competition in this case was to generate a urban planning in a very large area of a city which was completely empty for some historical reason. So one of the key problems that the urban planner have to find is the connection in between the different parts of the city. Without an empty zone, which one is the best path in order to connect important road from the left side to the right side, from the north to the south, and so on. So there are important roads which still existing from the urbanized area. There are parts which is completely empty. So the question is how to connect each other. In this case, we are in front of one problem which is quite common in urban planning: how to generate roads inside an empty area. So the plugin in Maya to create dynamic hair was able to generate connection in between left and right, north and south, and the smoothness of the road, which is necessary in every design of the road, somehow recall the dynamic of the air in the computer graphic. One thing which is very, very important in every kind of elaboration using parametric is that we are still not in front of strong intelligence. There is a sort of automatization in the process of creation of road, in this case. This application of Maya Air Dynamic tool, it is very good to minimizing the Tor network and the deformed grid, as the sentence mentioned, but at the same time means nothing. So finally, it is always necessary to have the intervention of the human intelligence to give a sort of meaning, to give the final output of the computer elaboration. So somehow we are still in front of an automatization, but then finally the human intelligence have to create the final output. This is very important in every form of discussion in between artificial intelligence and architecture. This part, it is composed by one of my brilliant students named Zhao Yafei, one of the key members in my office, which helped me to point out some key elements in the parametric tool and process to generate architecture. Some pictures in this page are already well known because we are in front of plugin. We are in front of software which we already used in the past class, but here we have a new concept that we have to express. In this picture, we illustrate one software named Finch. Zhao Yafei, in his slide, express the idea that robots can draw pictures. Designer will really be replaced in the future. Using Grasshopper and Rhino, it is possible to generate a sort of self-adjusting architecture. If you see the pictures, the animated picture in front of you right now, what you can see, it is a sort of self-adjusting software which is able to correct and actually to organize in real time the space inside a given boundary, the living space of the apartment. And this one is happening both in 2D and in 3D. Actually, it is completely the same. The idea in this software, it is that the robot, the software, using Grasshopper and Rhino with some system of parametric, it is able to generate all the possible plan according with a given parameters. For example, only modifying the shape of the building or the size of the apartment, automatically the software generated the optimal solution. On this point, I want to mention one critical element. I'm going to say the optimal solution, not the best solution, which is a concept which is already discussed in the previous class. And another point is this: there are no genial solutions, there are not brilliant solutions, something which can really innovate the design of the apartment. You cannot find any innovation inside those solutions. They are automatic, self-generating cases. But this one, it is only because the parametric, it is not artificial intelligence. Attention, make very clear. Parametric, we are not in front of a genius, real, strong intelligence, invention. They are simply an optimization. This one is very important. The parametric design tool, which is currently under development, uses data inputted into it on the sides of the building and local parametric regulation to create optimal internal plans, either in 2 or 3 dimensions. Again, as it is mentioned in these figures, we are discussing about optimal solution, optimization. So the parametric at most can generate a very quick output, but based on given data. No invention. What it is clear is we are in front of weak artificial intelligence. The output, it is somehow generated by the characteristic of the data which is inserted by the architect, by the human being, but at the same time there are some mechanization. It's a process of optimization, something that maybe an average architect even can't imagine. But what it is interesting in this case, it is a very good beginning for future development of a much higher and much complex solution. This picture that we already discussed in the previous class touch exactly the same topic. This is a project made by the Harvard School of Architects, created by Archigun. It's a software. So also in this case, we have animation that propose an optimized solution according with some intention of the architect. For example, the architect can reshape the boundary of the apartment or can do some modification, and automatically the output it is generated. So this is a very interesting and powerful tool in front of a new request, a new needs of the market, because we know very well that the client can interact with the architect and modify their needs moment by moment. Actually, the client and the architect, the operator in this case, can sit in front of the computer and modify and generate thousands of possible output of the project. And then finally the client or the developer pick up the one that he likes most, visually or functionally. That is not the problem. Again, this is a parametric tool, this parametric process, it is still weak artificial intelligence, it is automized, it is based on the parameter that the architect or the developer or the government insert inside the system, and it can generate a very nice and very quick output. Genius solution? Not at all, but a very good professional solution output in order to generate good and quick architecture. One very interesting case that it is developed in China, it is Xiaoku technology. In this case, it is developed a very interesting and complex interaction in between a computer and a human in order to create some initial optimization, a sort of optimization of the organization of district block or architecture or plan, which could be very useful for the initial stage of the design. It's very important to explain this kind of phase. Designer who has the ability and the experience in the urban design, urban planning, architecture planning, district design, and so on, they know very well that the initial stage, the first step into design is quite complicated because you are in front of a white paper, you need to start some sketch. For example, the technique of Alvar Aalto, the very famous modernist architect, is just to create some free form, let the fantasy run without any order, and finally he finds his own design. So very creative, very artistic, and it worked very well, simply because he was a great genius. But the problem is still there. In front of the white paper where the endless solutions are possible, which one is the best step in order to optimize the final output? This kind of technology, Xiaoku technology, is able to help the architect in the initial design, initial steps of the design. So, for example, if the problem, like in this picture, say that there are some necessity to optimize the distribution of the building inside a given area, well, this distribution could be, for example, optimized in terms of mutual relationship in between the building, or solar radiation, or ventilation, or optimization in between garden and the footprint of the building, or for example the height of the building or the form. What I mean is, at the very beginning, it is possible to generate some advice, some suggestion, some optimization in order to let the architect work faster and better. So it is not a software which is able to give the very final output, but more like an assistant designer. The one who say, dear architect, attention, if you put the building in this position, you may have some problem for the shadow on the building which is on the back. I advise to put the building in this kind of distribution, simply because they are more optimized, they are better in terms of function. And those parameters of the function, it is definitely insert at the very beginning. I'll give you again a very simple example, solar radiation. or energy saving, or distribution in between the building in the parcel and the surrounding, not too near, not too far, and so on. This is a very convenient element, a very convenient strategy for artificial intelligence in architecture. But as we discussed, are we in front of real artificial intelligence? In my opinion, they're in front of parameterization, weak artificial intelligence, a sort of output which it is generated by the input that the architect or the urban planner or the administration insert inside the system. One of the interesting points of this Xiaoku technology, it is that this is a sort of method for the optimization of the result. So once again, as this slide mentioned very clearly, there are some algorithms. We are not in front of an intelligent software, a software which is able to throw away the human architect and generate a plan, a design which is completely independent. It's very different. We are in front of algorithm, we are in front of parameters which have to be inserted by human. The software generate some solution, and then finally those solutions generate one output. The output, it is not the final. The real settlement planning need to be revised and weighted repeatedly after the initial plan it is generated. And this step, it is still done manually by human being. So, what happened in this case? We have some input, parameters, then it exists some self-generating output. The question is this output good? Well done? Is it a good solution? And then the human being must give some score, something like a professor gives the score to the homework of the student. It is good. Well, yes, it's okay. This part is nice. The other part is not so good. Try again, and try again, and try again, and try again. So this kind of weighted process, it is made by human. I think, personally, that in the future this kind of weighted can be done by neural network and it will be automated. I think that is the solution. This is another very interesting case that the literature report. Very, very nice, frankly speaking. Very nice, but with some controversial and even interesting output. We read together. The generation of the architectural plans through the relationship of rooms is the same as that of residential area planning. This is a classic algorithm-assisted design topic. Recent articles have been divided into two categories in the generation of plans. Number one, generate design models systematically through various parameters, including but not limited to the three-dimensional models, planes, elevation, etc., which is close to the parametric design that we previously recognized. Number two, to use the recent highFAR machine learning. For the learning of a large number of plane images, the plane it is generated according to the provided plane outline and some feature parameters. It's very clear, but give some comments which help everyone to understand the logic of these pictures. First of all, we are in front of self-generating architectural plane. Self-generating plane, it means that the architect has no action in the creation of the map, in the creation of the plan of, in this case, buildings. Try to check the figures on the right side. It is a picture from one book, divided page left and page right. In the page left side, we find some output, some scheme, we can say, which is in the square frame, which is generated by computer. This kind of plan, it is a classic, as I mentioned in the sentence, classic algorithm assistant design, which it means that there are some parameters, parametric numbers. Again, parametric design is basically numbers, which is inserted into the machine, and then the machine starts to elaborate according with some relationship in between different space, size, and so on. This kind of output, finally, it is adjusted to become an apartment, a plan of one apartment in this case. How many forms of apartment you can generate? endless. There are thousands of variations. The interesting fact is it is still not strong artificial intelligence, it is only parametric, but the very interesting point that makes this experiment very useful is the final output is very reasonable. It is a masterpiece of architecture? No, it is not. It is a very good standard product. I'll give you a very simple and even a trivial example, a note of myself. I love very much coffee. So if you want a masterpiece of coffee, then you must go to a master who are able to select a very good coffee bean, and then he has a very good machine for making coffee, a very good grinding machine. He has experience, he has a very large ability to create coffee, and then you can drink the best coffee ever. On the contrary, there are some other machines made by very big multinational corporations which can create a very good standard coffee. So the coffee is good 100% of the time. It's not the best, it is not the worst. It is a very good average coffee. It is industrialized, everything it is parameterized, but you will never reach the best of the best. Maybe the top 70%, but to get the masterpiece of a coffee, you must go to the master. It is exactly the same in this case. You will never get a masterpiece of architecture, but you will get a very professional and logic organization of the plan, which is made by parameters. So basically, no mistakes, no any dramatic problem in this kind of organization. A bad architect can make a disaster. This kind of software never made a disaster. The output is very good, but it is not the work of a genius. This is the meaning. In the process of generation of the plan, as the sentence said, there are three methods. One, it is a generative design models, which follow parameters. The parameters generate one output, and this output, it is only parametric. Then there is another process which is a little bit more intelligent, which is based on machine learning. What is machine learning? It's a very simple concept. You have a child. This child go to school, he learn mathematics, language, grammar, art, and so on. He acquire information from the teacher, store in his brain, and he become an adult with a large culture. This is typical of the human being. The machine learning is completely the same. Of course, without the intelligence of the human being, or at least with a different intelligence compared with the human being. Machine learning, it means that in the memory of the computer, in the memory of the machine, you have thousands and thousands and thousands of examples of good plan. And the machine learned that the human being, these strange living creatures, likes more this kind of organization and they find more successful, or at least the performance is better with this kind of form. So the machine say, without understand, the machine say, this output somehow it is better than another output. I don't know why. I am a machine. I don't have the needs of the human being to live in the apartment because I live in the memory of one hard disk. That's it. But these strange creators called human being likes very much that kind of output. So in that case, we are in front of one solution, one output, which is based on cases. Machine doesn't know why it's good, but according with the preference of the human being, that is good. So this is why on the right side of our picture, we have this kind of strange conformation. This is a huge plan of basically one apartment. What we have, it is an apartment with dozens of rooms or even hundreds of rooms, all organized in a very intelligent way according with the previous input that the human being put inside the machine or the machine learned by themselves. So the architect says, I want one apartment made by 256 rooms. And then the machine starts to calculate and generate this kind of strange output, which in my opinion is very funny. But it is not a great architecture. It is a machine-generate architecture, and it is very evident, but it is a very interesting case of design process based on parametric and algorithm-assisted design. Again, we want to point out the two processes that it was quoted in the previous slide. The first category of parametric design, it is to improve the efficiency of the architect. The output and the process that we have seen before, this kind of automatic process to generate a plan and a 3D model of the building, that kind of process, it is still parametric and based on numbers, parameters, structures, logic. So in this case, this form of production of architecture, it is automatic, based on software, but it is a completely different system of designing architecture. The interesting element in this process is some possible unusual output could come out because it is still generated on abstract process, numbers, parameters, relationship. It is still not an element which is based on machine learning, which we will touch after a few minutes. This case, it is quite interesting in my personal opinion, because the parametric design, it is still not artificial intelligence, but it is based on standards, on mathematical relationship. If the mathematical relationship are smart enough, some unusual conformation come out and some surprising element could be found out. What it is important, and this is why it is not still strong intelligence, is all the system, it is based on what the human insert inside the machine. If we human we don't insert anything, then the machine is completely stupid, flat, empty, so no any possible output. This is why it is not intelligence. If you take an animal or a human being, even without education, he or she can show his intelligence. But a parametric process without the initial parameters input in the machine do nothing. This is why it is not strong intelligence, it is a weak intelligence. This kind of parametric process of self-generating architecture can be very useful, can be very powerful in coupling with BIM system and in the optimization of the performance of the building. In this slide, we also mention processing and use of the material and the process of construction. So, in order to conclude this part, we can say that the parametrization of the architecture, even if it is still weak intelligence, even if it is based on initial parameters that the human being have to insert inside the machine, inside the computer, in this case, we are in front of a big advantage in terms of optimization of the output. Something like BIM system, something like optimization in the material processing and in the process of construction. The second type that we mentioned before, the machine learning, it is based on trying to manually construct flat data structures, but using machine learning method to approximate. What does it mean? It means that, yes, it is true that the human being or even based on an automatic process, the machine can learn from a project which is already done in the past. It is based on example, imitate, mimic. But it is also true that some unusual combination can come out. In my opinion, the machine learning is a little bit less interesting than the parametric, because the machine learning has no fantasy. It is only based on previous example. Much more interesting it is if the machine learning it is joined with some other process of calculation. For example, machine learning based on existing example plus a sort of random modification of the existing parameters in the limit of a certain kind of range. If you remember our discussion in the previous class when we discussed about crossover and mutation, that is the point. What happens if the machine learning based on existing case after we can insert some element of crossover and mutation? That, in my opinion, is a very interesting process of elaboration, probably one of the way to elaborate new form of architecture based on machine learning. In fact, the strict machine learning process is a little bit stupid. It is something like, dear machine, if you learn these 10,000 examples, you can be a good architect, which actually it is not, because architecture it is also invention. Architecture it is also quality. Architecture it is based on the feeling of the human being, something like a poet, something like a painter. There are no objective reason that a painting it is better than another one. It is only the quality, it is only the feeling in front of a page of literature, in front of sketch, in front of one beautiful figures. It is the emotion that piece of art stimulates in the human being. As we mentioned in this slide, the disadvantage of the process of machine learning is that the users has no learn anything except plain imaging. For users here, we intend the machine. But to make this floor plan usable, it is also need architect, interior design, basically the human being. In order to conclude this section, the machine learning is quite stupid. It is simply a collection of given example. The output it is based on previous case. Is it good? The machine doesn't know. The machine only know how to generate another plan based on the existing example. Nothing new, or better, if there is something new, it is still based on the past. It's a sort of loop. In my opinion, this process is very dangerous because it generates academia. Architecture, it is always a revolution. This is what I stress. Architecture, it is based maybe on the personal taste of one architect, but that architect can change the world. This slide takes back some of our discussion that we have proposed just now. It is very interesting when the machine learning it is joined with the neural network. Yes, because the neural network it is a very powerful system to solving problem based on self-adjust weighting. We will discuss in the next and final class. So when the neural network process it is applied on machine learning, something very interesting can come out. And then in this case we really can talk about artificial intelligence field. So neural network connect with the machine learning, but in theory neural network also apply into parametric. That is a very interesting direction, and in the future for sure the engineer will run into this direction. So neural network plus machine learning, neural network plus parametric. I remind you that a neural network it is on the back of all the software which win chess and the game of Go. There are currently 4 types of supervised neural network for architectural design. Attention, supervised neural network, it means the neural network are supervised by human, which means the input data or revising data after the output is still human. So the 4 types are convolutional neural network called CNN, map image to vectors, generate an adversarial network, GAN, map image to image, artificial neural network, ANN, map vector to vector, recurrent neural networks, RNN, map order vectors to vectors. Now we don't have time to go deeply in these 4 categories. I strongly recommend you to study the logic and especially how it works, but basically it is a process of coding. In my opinion, that is a very powerful methodology to generate architecture using artificial intelligence. Now we want to give you some example how can the machine learning be used in architecture design. We propose 5 5 categories. Number 1, mining the data and transforming it with a clear data structures. Number 2, find the applicable neural network type. Number 3, adjust the network setting. Number 4, train the network and repeat the point number 3 until the result is satisfactory. Number 5, apply the trained network to identify or generate other tasks. So this kind of process, it is quite logic. First of all, we search data, it is called mining, and transform those data in a sort of system based on an intelligent framework. Then we must find the right neural network and train the neural network. Let the neural network become somehow intelligent. Then finally, with our own intelligence, adjust the neural network, and then finally teach the network how to become optimized, looping, come back again to the adjustment of the point number 3. This one can be done without the human intervention. And then finally, this kind of complex system is ready to generate architecture. In this case, in my opinion, we are in the direction of real intelligence, because we have machine learning, which is quite stupid. Get data without understanding what you are reading. Just repeat, get, but without understand. And then finally, we apply this kind of huge amount of data, could be plan, could be numbers, could be performance, could be anything you want. We apply this kind of data into neural network. This neural network have to be optimized, and then finally the system know how to use the data acquiring. This picture, it is one case. It is not properly a design of architecture, but it is one case of application of intelligent behavior into urban planning, urban design, urban analysis, what we have called DDA, data-driven analysis. In this case, there is a sort of intelligence which recognizes things into a picture. Now, in this case, we use a picture, but it can be a CCTV camera, it can be a movie, it can be what you want. So we train the system to be intelligent in order to recognize what is a car, what is a person, what is a bicycle, what is a public light, what is a building, what is green, what is a road, what is what you want. Then we give a lot of examples of car. So the car has different shape than a bicycle. A bicycle has a different shape than human. So we train the system and tell the system what is a car, what is person, what is building, and so on. And this is machine learning. And then we give to the machine a sort of behavior. The machine understands how have to react in front of a certain kind of stimulation. This is a very important case of application of artificial intelligence into architecture, in detail into urban analysis. This image, it seems quite stupid, but actually it's very intelligent. In this case, it is used a heat map generated by machine learning. In this case, there is a camera which recognizes the path of the people inside a certain kind of urban space, and then thanks of the heating map, the map generated by heating, which could be a thermal camera or simply a visual camera, the machine recognize the path of the people, how the people use the space, basically where they walk. And they can give a sort of weight in the space that is more popular. This is another very important application in urban study. Another very interesting application of artificial intelligence and architecture, it is illustrated in this picture. If you remember, in the past, we discussed that one application of the artificial intelligence is in recognize pattern. For example, you have a lot of data, and for us, human beings, those data are simply numbers without any meaning, but the artificial intelligence can recognize a sort of pattern in the numbers. For example, they can recognize signals, repeat the code, repeat the number into a very complex space. Also, the recognition of the face, which is very useful in security, is another case in this direction. So maybe a human being cannot recognize very clear the face of a criminal, but the artificial intelligence, it is much faster, much smarter in terms of recognition of face. So it is easier to catch criminal. Now, don't consider the criminal, but consider the architecture. There is a project named the Rosetta Stone, which is a sort of catalog of good design, very nice architecture, which the people love mostly. So the quality of the design, it is not inherent to the architecture itself, which basically is a concrete, glass and wood, that's it. But how the people prefer architecture, what we consider beautiful, what the architect like. It exists a lot of architecture. Some architecture is ugly, some architecture is good, is beautiful. People prefer, for a certain reason, a certain kind of architecture which is considered interesting, which is considered good design. And then the artificial intelligence recognize the quality of the design according with the preference. Attention, in this case, we are not only in front of style, output, visual, but we also can recognize the logic of the organization, the structures of the building, the idea, the concept. Basically, the architecture, it is a very complex matter, not only visual, but also based on space, spatial distribution, or organization, or function, or beauty, or another parameters, light, for example. What we consider good, it is recognized by the machine learning and categorized. So finally, the system, the artificial intelligence, can generate one design according with the preference of the users or the architect. This is another very interesting field in artificial intelligence and architecture. Another case that we are not going to illustrate, to describe deeply, but we need to at least mention, it is the collaborative design based on MR, where MR means mixed reality. We know very well that the mixed reality, it is based, for example, on helmet, smart glasses, virtual reality, virtual touch, and there are a lot of very interesting experiments in terms of VR, virtual reality. The architecture should not be only physical, I mean in the real material world, but also can be virtual. We already illustrated in the past class the idea, the architecture, the space actually can become virtual space. This is exactly what we mean. There are a huge branch in artificial intelligence which is related on mixed reality, mixed physical and virtual. Unfortunately, for reason of time, we are not going to discuss this topic. Then we have a key question. We have seen what artificial intelligence can do for architecture design, and now we have to briefly illustrate 3 elements that artificial intelligence cannot do. First of all, in the current state of the research, artificial intelligence have to be based on machine learning. So it exists a human architect which create previous design, previous cases. It exists users and experts who say this experiment is better than another one. This building is ugly, this building is beautiful, this is bad, this is good. So the machine can learn according with human preference, human input. A second weakness of the artificial intelligence today is that every time the artificial intelligence give an answer, give an output, give a project, it must exist an experienced architect, a professional, who is able to generate the final output. Basically, we must adjust the output of the artificial intelligence. The artificial intelligence nowadays cannot generate a mature project. The third point is basically a consequence of the first two. Architecture, it is the creation of form and, in my personal opinion, even more strong space. Now, the concept of space, it is too difficult for today for the machine to understand. So, if the architecture is a form and space, artificial intelligence nowadays only can help the human being in the generation of the design and especially in the creative and innovative ideas. In this moment, the artificial intelligence cannot substitute the architect. So the architect is still very important. Now we are in front of machine learning. Machine learning means that it exists something that human being create and input in the machine, even simply if we put parameter, data. For example, the machine can't understand the environmental parameters, the thermal comfort in one building. It makes no sense for a machine. So we, human beings, we still need to create data, set parameters or set form to insert into the machine. Nowadays, this is the state of the art. So this is the part illustrated with the help of Mr. Zhao Yafei. We thank Zhao Yafei for the contribution in this lesson and in general in the contribution of our office. Thank you very much.